Hello, everyone. We will do some more of the problems from the review. I've got some of the answers in here already. Anything that I have an answer for, you can see the explanation on the version or the video that I released on Tuesday. In the meantime, we'll go through and I'm going to pick and choose some questions that I think are a little bit more on the tricky side or ones that I didn't do on the Tuesday version of this, starting with 11 through 13. We got this chord that looks like it might be perpendicular. In fact, I'm given that it is perpendicular, which right away I'm going to put these markings on there because if it is perpendicular, then those two segments must be congruent. We'll see how that comes in handy later. We're given that MN is 58, so all the way across this circle, the diameter of the circle is 58, which means each half of it, each radius must have a length of 29. And so this is 29. We also know that NR is 9, which means SR must be 20. SN is 29, so if part of it is 9, the other part must be 20. And we actually just found SR to be 20. SP is a little bit of a hint for us. They're asking us how long that segment is. Well, if the radius of the circle is 29, then that must be 29. And then finding PQ, well, I'm not sure how to do that, but I know how to find PR. And because this is perpendicular, that means that PR and RQ are the same. So if I can find PR, then I can just double it at the end to get PQ. And because these are perpendicular, I've got myself a right triangle here where the hypotenuse is 29, one of the legs is 20, and the other one is unknown. So 20 squared plus PR squared must be equal to the hypotenuse squared, 29 squared. So RP is going to be the square root of, I'll have to do 29 squared minus 20 squared. And so I'll go ahead and do that on my calculator. And I get the square root of 441, which is 21. Then if PR is 21, then P all the way to Q must be double that. It must be 42. So we've seen a lot of different problems like this in this chapter, some going in one direction. This one's going a little bit in opposite direction. 27 through 30 are all going to use the same idea, and this is an easy one for us to talk about because we've done a few of these problems. And if you haven't noticed this yet, then maybe you've just been doing the problems, not really thinking about them. But one thing you should have noticed as you've gone through and done multiple versions of this problem is to notice that if I've got a quadrilateral that's inscribed in a circle like this, the opposite angles turn out to be supplementary. So if angle P is 84, then angle M must be 96. And the reason for this has to do with intercepted arcs and how if angle P is 84, then arc QMN is double that, and then all the way around a circle is 360 degrees, so we could find this arc and work backwards. But at this point, we've done it so many times, I'm just going to skip straight to the punchline and say, if angle N is 59, then the angle opposite must be 180 minus 59, and that would be 121. And so let's take a look at these. QN, now careful with this, QN could be going around through point M or point P, but it's going to be the minor arc. It's going to be the one that's less than 180 degrees. So actually, I'm going to look at these and say that if this angle is smaller, that means this arc is going to be smaller also. So double 84 was 168. And if you put 192 for that one, then you did arc NPQ instead, and I guess that's what I'm asking for next, so I might as well write that in there. Whoops. This one's 192. And if you're going more than halfway around the circle, then you need to use 3 letters to show that you're going through that point. Otherwise, it's assumed that you're going the short way. Angle M we found already is 96. I suppose I don't really have to do this, but I've come this far, why not? And then opposite angles of a quadrilateral inscribed in a circle, as I mentioned, they are supplementary. 33 through 36 is a good one for us to take a look at. We're given a couple of side lengths. We're given that this is perpendicular. Again, if this radius is perpendicular to this chord, that means that it's bisected, and A must be 12. We also know that, let's see, I know that B is C and D put together. Ooh, how about this? I also know that the product of these, the parts of the chords are equal. So I can say 12 times 12, the two parts of this chord, is equal to 8 times this segment, 8 times B. And so I will take 12 times 12 and divide by 8 and find that B is 18. I'm not sure why I wrote that over there. And then if I know that B is 18, then I know that all the way across this circle is 18 plus 8, that is 26. And if the diameter is 26, then the radius is half of 26, which is 13. And then I know that 13 plus something is going to add up to 18, and so D must be 5. 18 minus 13. As I mentioned, you can go ahead and skip 38 and 39 and 40. That's a topic that we did not learn about. 42 is basically like 43. Let's see. These are all similar. I think I'll maybe do 46 here. We're given arc MS is 34. And NR is 118. And then we're asked for a couple different things inside of here. SRM, ooh, angle SRM, that's an inscribed angle with an intercepted arc of 34 degrees, so that is 17. The inscribed angle is half of the intercepted arc. NMR, NMR, well, that's another inscribed angle, so its intercepted arc is 118, and MR is going to be half of 118. That must be 59. MPR, well, I am going to have to do a little bit of work to figure that one out. I'm going to have to use the fact that inscribed angles, oh, wait a minute. I found this angle was 17 and NMR was 59. I take it back. We're going to be able to do this without going through that process because we've got two of the angles inside of a triangle. So of course we can find the third angle inside of the triangle. I'll just do 180 minus 17 minus 59 and find that that angle is 104. This is kind of interesting. What we're doing is figuring out why the formula exists that exists for finding the measure of an angle like this. So we just found out that the answer is going to be 180 minus 104. We're going to get an answer of 76 for this. And that is the same thing that we would have gotten if we had used the formula that says that this angle of these intersecting chords inside the circle is the average of these two intercepted arcs, 118 plus 34. Divided by 2, add them up and divide by 2, and that's another way that we could have found that angle. 47 and 48, let's see, 48. That's pretty similar to one that we did in the other video. Let's maybe just take a look at one more of these. I think I'll go down here to this one. Give an equation for a circle with the center of 1, -2, and a radius of 10. So pretty straightforward here. We do x minus the x value squared. Definitely a formula that you're going to want to have at your side as you're working on the test at the end of this week. Y minus the y value. The y value is -2. Y minus -2 looks like y plus 2 squared equals the radius squared, and the radius is 10, so the radius squared is 100. And then they say they want us to use a 6/8 Pythagorean triple to give 12 lattice points on this circle. So let's see what I'm talking about there. First, I'm going to graph the center. 1, -2 is right there. And so there are always 4 easy points to be found by going up and down and left and right by whatever the radius is. So I can take this point that is 1, -2, and if I go up 10, that brings us to 1, 8. -2 plus 10 is 8. Or I could go down by 10 and subtract 10 from the y value and get 1, -12. Or I could go to the left and subtract 10 from the x value. Or I could add 10 to the x value and get those 4 points. So going up by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 brings me there. That's the first point that I found, 1, 8. Or down 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, just off of my graph paper. So there's the second point, 1, -12. To the left by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is -9, 2. And then finally to the right by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go, again, just off the graph paper. And so, excuse me, those are 4 easy points, but this says 12. But it also reminds me that there's a Pythagorean triple, a 6, 8, 10 Pythagorean triple. So what this is saying is that if I go over by 6 and up by 8, that distance, the resulting distance, is a distance of 10. So over 6, up 8, over 8, up 6, over 6, down 8, over 8, down 6. And we're going to be able to add a whole bunch of different points by adding and subtracting 6 and 8 to my coordinates here. And so I'm just going to graph these, and then we'll figure out what the coordinates are next. But I will go to the right, 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5, 6, 7, 8. Here's 1 point. Or I can go over 8 and up 6, 2, 4, 6. I could go to the left by 8 and up 2, 4, 6. Or I could go to the left by 6 and up by 8. Or I could go to the left by 8 and down 6. Or to the left 6 and down 8. Or finally, I could go to the right by 8 and down 2, 4, 6. Or to the right by 6 and down 8. When you take a look at that, if we're going to play connect the dots to create a circle, that's going to create a much more smooth circle than the way we had it before. I think I'm going to try to speed this up by just using my text box. So starting at 1, -2, let's see, I'll start by just adding 6 and adding 8 to get 1 point, and then adding 8 and adding 6. And these are all being added on to the point that I was given. 1, -2 is the point that I'm starting with for all of these. Or I can add 8, no, add 6 and then subtract 8. That'll bring me down to -10. Or add 8 and subtract 6. So at this point, I've gotten these 4 points over here. Now I've got to subtract from the x and y values. So 1 minus 6 gives me -5. Or -5, -10. So that's these 2 points down here. Or I could subtract 8 from the x value, or subtract 6. Or sorry, I've already subtracted 6. Let's see, subtracting 8 and subtracting 6 from the y value gives me those points. So those are the points that I found by doing this. Why not? I'll finish up by trying to draw this graph, and even with those points, this is turning out to be a little more lumpy than I was hoping that it would be. Drawing with a mouse is tricky for old people like me. There we go. Not terrible, but not great. And that's the rest of the review. So there's a few problems that we haven't finished yet. Reminder, don't worry about questions 38, 39, and 40. But the rest of this should be a good preparation for the test. If you're looking for more stuff to do, let me know. I could probably dig out some other stuff for you. But all you'll have to do is to finish up this review and then get ready for the test that'll be at the end of this week, the last thing you will do for this class. So hopefully you're all doing well, and let me know if you're not, if you need some help from me, and I'll get in touch with you. Otherwise, have a great day, and we'll talk to you later. Bye-bye.